I'm happy that so many of you are actually interested in this topic. Let me start with a little bit of expectation management. So this will not be a deeply technical talk. This will be a talk about how we approach things, what is important to us, and what have we actually learned from doing this now for roughly 10 years. A lot of this is my personal insight and also what my team discovered and found to be important over time. So I will make some technical examples, of course, and I expect that you have some general overview of what security is in embedded systems, but I will not go deeply into the technical things. Let's start with a little bit of context so that you understand a bit better where I'm coming from. I'm Martin Lang. I work for BMW Car IT GmbH. We are a fully owned BMW subsidiary in Ulm, Germany, and we work mostly on three kind of things. This is software development, integration, testing. First, for infotainment systems, this is the area where I come from, but colleagues of mine also do driver's assistance topics and autonomous driving topics, and we have a strong focus in Ulm at Car IT GmbH on developing the platform, so the base software that is then running the individual applications. So we have a lot of system engineering background here. What does my team do? We are an agile engineering team. I currently have 6 security engineers, 1 product owner, a product manager for security features, and I have 3 individual project managers that take care of the individual projects that we do. And when people ask me what you actually do, I usually say there is kind of 3 big topic areas that we do. No, this is the wrong direction. I need to press the right buttons, otherwise it doesn't work. First of all, we do security software development. So we do cryptographic support functions, libraries. We make it easier for people to work with crypto. We implement protocols when this is needed. We work on privileged execution wrappers. I will get into this later on a little bit, also to make security functionality more easily accessible to people that do develop their applications on top of our platforms. And we work on IPC policies and IPC policy mechanisms. This is mostly because I come from automotive, obviously, so we have some automotive-grade IPC mechanism that didn't come with the built-in IPC security mechanism. So this is also what we maintain out of my team, and some more things. So you can imagine it's a lot of smaller stuff, not that huge software components that actually do things, but rather small support components that you need when you build such a big system. The second thing that we do is system configuration and system integration. I just sometimes say, well, doing this feels a lot like being a Linux system administrator, because this is the things that you usually do. We work on system deconfiguration. We work on SELinux. We do actually work on not only the IPC policy mechanisms, but also working on how to create access control lists for this. We work on implementing secure boot. We work with dm-verity, and so on and so on. So these kind of system level things that we do, that you would do when you build such a system. And last but not least, we do in-house security consulting. So people come to us and say, we have some cool idea about this feature that we want to implement. What do we need to do in order to implement this in a secure way? And then we help them to understand the architecture a bit better, their own architecture, and give suggestions how a secure implementation would then look like. And in addition to this, we also take care of this UNECE regulation for cybersecurity for cars. You can imagine this. I'm pretty sure quite some of you know the EU Cyber Resilience Act. This is actually the regulation that is kind of the same, but that applies to the automotive world, which is a bit special. But from the idea, it's kind of the same. Do this for the BMW Yocto-Linux platform. So we build a Yocto-based Linux, which we call Node 0 internally. which contains all the basic things that you need in order to build a BMW ECU. And we put all this different security functionality that we think is important for all the ECUs. We try to put it in there. But of course, there are some things that you need to do in a hardware-specific manner, like secure boot. This is then done on a per project basis. And out of my team, we actually do this in the head units. So this is the big thing that contains the navigation, entertainment functionality. And this is also this kind of big projects that I mentioned. So also, for your understanding, what is it when I call this like a big project? When I look at these head unit projects, then we talk about having around more than 1,000 people that have direct source code access to this, not including third-party development. So my guesstimate is that in total we have 2,000 to 3,000 people that actually contribute to these kind of projects. And we have more than 100 services running on one embedded Linux system. So you can imagine that quite some of the problems that you have in such a project just stem from its mere size. And this is also what I'm mostly focusing on. If you have such a large project, what are the important insights that we have? And I would like to start with an introduction to give you some idea on what is actually important to us based on what we have seen. So what are the things that we take care of? And the most basic thing, and I guess it's the most basic thing if you talk to security people in a lot of cases, is that you need to get the least privilege principle right. So it starts with the very, very basic things. Everything should be separated. It should use a different POSIX user. It should not run as root. If it needs elevated privileges, try to use the Linux capability mechanisms to just limit it to what it really needs. Your system should have a firewall, of course. And also, if you do IPC, then you need to have IPC access control lists, because otherwise you have free privilege escalation over your custom IPC mechanism, which gives you nothing. So this is really what you need to get right. And you would think that this is simple. It isn't. I can tell you this, when I started, I had quite some discussions about it's necessary that things don't run as root, and how you solve the problems that arise from this by placing files in the file system that now need to have the right user. Device nodes need to be correctly labeled. So all of these things that you need to do, where your life is actually easier if you run as root, but you really need to do them. So we do spend quite some time on this, still up until today, I would say. But this is the most important thing. The second thing that I think is really important is that we need to ensure that all the well-known industry best practices are applied and correctly implemented, which means that all of your stuff should, for example, have address-based layout randomization, should have a non-executable stack, should be compiled with all the binary hardening options that we have, think stack canaries, think Fortify source, and all of these kind of things. When you have a Linux and you debug things, you often have SSH, you have a serial console. Well, you should think about this as well. You need to think about log sanitization, because you can imagine embedded systems are often debugged by extensive logging, at least in the automotive world. And people tend to just dump out all kind of stuff, and you need to be careful, because otherwise private keys might also be dumped out, secrets might be dumped out, passwords might be dumped out. Yeah, you need to take care of this. And last but not least, I think timely updates. If you have vulnerabilities somewhere in your code base, you need to take care of this. And I would even go to the extent of saying that this is to some degree an unsolved problem for everyone in the industry, at least if we think about the support timelines that we now have. When we think about automotive, it's at least 15 years, in some areas even longer. If you're done with that, so the next thing that is important to us, I would say it's trusted computing, because you don't want that ECUs are manipulated, because this is then potentially not only a security, but might also be a safety problem for customers. So we want to have an effective secure boot mechanism in place. And then we want to have dm-verity for the following root file systems, so that they are protected against manipulation as well. And when I think trusted computing, I always say, well, only code that is somehow being authored by some trusted entity should be executed. So what we also try to do is we enforce a policy that either your file system is read-only or it should be mounted with no exec. So if you have some read-writable storage, we mount this as no exec so that no code can be executed from there. You should take care of anti-rollback so that older vulnerable software versions can't be installed. And when you have customer data, you should think about disk encryption, encryption of crash dumps, because obviously crash dumps can contain private keys, can contain passwords. So if you just dump them on some convenience partition so that later on people can use them for development, this is bad. Once you're done with that, we actually think you could revisit the least privilege principle and add some more layers, because there are some fancy things that you can do here, like adding a hypervisor, using a mandatory access control mechanism like SELinux, implement some sandboxing based on containers or the different namespacing mechanisms that Linux provides, or based on seccomp. And only then, I think you can think about all of these things that security people usually like to talk about, which is special trusted applications, special security scanners, special security co-processors. Yeah, this is the fancy stuff. But at least in my personal opinion, this is worth nothing if you haven't gotten the rest right. But security people tend to talk mostly about the top, and I want to talk today a lot about the bottom, which is the boring stuff, but the important thing. So talking about this big projects that we do, I think the most important thing for me is talking about the responsibility model. What do we do? You saw the team is not that large. We are in total about 10 people against like 3,000 developers. How do we organize this? We understand ourselves as a team who is like providing guidelines, rules, and infrastructure. And the idea is that we set the guidelines for secure software development basics. We provide infrastructure for user config, privilege config, and for security policies. And in addition to this, we also work on the platform features. So when you need to do something like secure boot, this is something that my team works on together with the hardware vendor, which in automotive speak is often called the tier one. Because this is something chip specific, so it might be done by the hardware vendor, but we still collaborate with them on implementing all of these things in a correct way. And then on the other side of it, we have a lot of development teams, and the idea is that they implement their features and they also take care of security, but in a kind of a self-service manner. So they really take care of the security of their components. If they need elevated privileges, they configure them themselves with a little asterisk. And this says, like, we review them, we provide supervision, and we provide support if they don't know how to do things in a proper way. So the responsibility split is that really my team is responsible for platform features and guidance, and the development teams are really responsible for the security of their software components. And you might have noticed one interesting thing. I told you a lot about things that we develop. So my team actually is one of these development teams in a lot of ways. So I think this is something that is important to notice, because this makes us understand how software development on those platforms work. So we really need to live our own processes that we try to enforce on all the dev teams. And I think this is really something that I would consider to be a best practice, because often you have security guidelines, people tend to ignore them because they are not doable. Well, we do our own processes every once in a while. If they are not doable, we notice. But what are the platform features that we have in this Node 0 BMW Linux platform? Let's have a brief look. So we do permission management, which contains standard user management things. We provide an SELinux policy, which is based on the open source reference policy. We take care of debugging of the platform on a debug mode. We provide features for networking. So we have firewall implementation, we have an IPsec implementation, MACsec implementation, all mostly based on open source software, just with a thin wrapper around that integrates stuff for key management, for interacting with our lifecycle management, and for all the bootstrapping that you need to do. So normally you would write a config as a system administrator. In our case, we have a piece of software that writes the config in order to get all of the open source stuff running. We have some security software. So as I said, we do IPC ACLs for dbus and also for vSUM-IP, which is this automotive IPC layer that we have. We wrote a small Polkit replacement called SmallKit. This is currently, should be open source soonish. We had the problem that Polkit loads like a 30 megabytes JavaScript library in the background. This is not good for early startup use cases, but we like what Polkit is doing if you want to have permission management on systemd unit control. So this will be open source soon. We have a cryptographic support library that makes crypto in OpenSSL more easily accessible to C++ forks, because OpenSSL API, well, it has been becoming way better with OpenSSL 3, but it's still difficult to use. And we do privileged execution wrappers. So for example, we have a tool that you can ship signed scripts, and then depending on the signature, they may be executed with elevated privileges. And then we have build system infrastructure, which is not really shipped as part of the final product, but it's rather what we build so that projects can then be integrated. This is, for example, for secure boot signing, we have a PKCS11 library that interacts with BMW signature servers so that you can easily integrate tooling that is provided by SOC vendors that can talk to PKCS11 HSM, and we have then some, BMW cloud-based thing, essentially. We have tools for providing dm-verity images, and we have actually tools for hardening, checking if all the hardening guidelines are being stick to and stuff like this. And I will give you some examples. Let's start with a very, very simple example, user and group management. How do we do this? I said we do Yocto, so there is a recipe. And the recipe, we just have one recipe for everyone, where people can just like add their users, assign a UID, assign the secondary groups, and the same for groups. So people can just create shared groups if they think they need shared groups, and they can assign an ID. And the idea is, why do we do it like this? So normally when you think upstream Yocto, everyone in their recipe can create a user. I said we want reviewability. Having this in a central place makes reviewability way easier, because we want to see if people start sharing data across large groups of services, which would most probably violate the least privilege principle. So we have one thing so that all the changes here are being reviewed by team. If they look suspicious, questions are asked. And we just like pre-allocate UID ranges to domains so that they can mostly do this themselves with not a lot of interaction. So now people have a user, they want to start their service, and we are, I would say, proud users of systemd, and I would even consider us to be power users of systemd. So we really like it because it gives you a lot of freedom, and it helps us to manage our rather complex startup of the system. And so the basics probably you can assign a user and a group and supplementary groups as part of your service file. And this helps us a lot because then the domains don't need to implement this. They start as root, they drop privileges, and all of this is just being taken care of by systemd. So there is a lot of things that can't go wrong if systemd starts them already with the right user. And if they need elevated privileges, what we nowadays just do is we assign them via ambient capabilities. Also, same here, no need to start with privileges and then drop them in the right way. We can just say, this is what they get, and it's easily reviewable as well. And the same for environment setup. So you can use exec start pre with plus or exclamation mark to run something as root if you have a small startup action that needs to be run with privileges, and then the main thing starts without privileges. And you can create a runtime directory also by systemd. No need for the service to start with elevated privileges, create runtime directory, and then drop privileges, because this is where things can go wrong. The last thing, this is not that known. You can actually do quite some sandboxing with systemd out of the box. And there is functions that are based on namespaces. So for example, private temp. If you use this, systemd will create a new mount namespace for this process, will create a new temp fs for temp, and bind mount all the rest of your system. And the same for protecting kernel tunables, protecting the C groups, or you can define read-only path if you want to have things here. So this is really, I would say it's low-hanging fruit because people can easily just configure it in their service file, don't need to think about it, and it gives you already quite some isolation. The same for seccomp. So you can say, well, there's a system call filter where you can just block out all the arcane system calls that are available for various reasons, but are not really used by anyone. And you can, block architectures that are not supported. You can also protect all the kernel module APIs so that there's just a small seccomp program that will be installed then by systemd that is then protecting what the what the service can actually do. So so this is my personal recommendation. If you don't do this, have a look into this because it's rather easy to implement and it comes at, I would say, acceptable performance overhead. And you don't need to do a lot. So I think this is low-hanging fruit. How do we then work on service files? So this is something, well, I said we have over 100 services, so people often change service files. If we would review all of these changes, we would not be able to do this. So we have some rules that we want to automatically check, and we have a utility for this that we call blame-o-mat. And this automatically checks if the rules that we have for service files are being sticked to. And if not, then there is an exception database which lives in a Git, and it checks if this is already known. And if not, then the CI job will just fail. So assume now we have a service, for example, managing MacSec that needs some elevated privileges for network administration and for raw network access that they would like to have now as an additional ambient capability. They would now need to raise a PR to the exception Git and provide us a machine-readable version of the exceptions that they get, plus together with a human-readable explanation why this is needed. This is then actually reviewed by someone from my team if this makes sense, and then merged. And once this is merged, the tool says, yes, you can now merge your service file because this is now good. One of the things is I would be interested in feedback. Maybe people want to have this as open source, or maybe people think this is trivial and it's not needed. You can give me some feedback later on. Let's talk about a bit more difficult things than basic stuff. SELinux rollout. So SELinux is a complex beast. I think everyone who has worked with this would agree to that. Why do we do this to ourselves? Let's say we also do Android at BMW, so we needed to work with it anyways. And I also think that doing mandatory access control is for such a large system something that you would consider state of the art nowadays. So we did start looking into this, and I think it's a good fit for an embedded system where users just don't randomly install stuff, but it's essentially fully curated during the development process, so there is no unexpected things coming up. And the ref policy is actually quite good nowadays, so you don't have to do a lot of development for the open source components. You can really focus on developing for the components that you add. And let's see how we apply the responsibility model that we have here. This is essentially, I said in the beginning, we do guidelines, rules, infrastructure. So for the SELinux case, we provide a repository to put stuff to. We provide some system-wide macros for stuff that almost everyone wants to do as an interface. We did detailed how-tos, so we wrote a cookbook on how to getting started writing your own policy file. We even did a video tutorial on the SELinux basics, so we explained all how this works, what you need to do, how to get started. And a lot of people actually watch this. They still watch it until today, even though I think this is now more than 5 years old, and we get very positive feedback on this. So if you're ever getting into a scenario where you need to roll out such a complex thing, actually doing this kind of thing, in my experience, does pay off. And then, of course, you need some individual consulting. We in the beginning had weekly consulting sessions. People could just join in for listening or book a slot to discuss their little problem. And this helped people a lot to get going. And yeah, in the end, we reviewed all the policies people wrote. We still do this as a quality gate. And yeah, we ourselves implemented the system-wide policy. So all parts that are not services that are written by some other development team, by just applying what the ref policy does, plus a little bit of tweaking. And then, of course, the development teams used all our resources to write policies for their services. So this is essentially how we approach this. How do you then roll this out? We did it in the following way. We created bare bone policies for all the services that already existed, that just gave them an SELinux type, and we put these types into permissive. This gave us the opportunity that we at some point in time could put SELinux on the whole system into enforcing, and everything that already had a good policy was now being enforced. Everything that didn't have a good policy at this point in time was running in permissive. And then we monitored the logs that came out of the system that we had from automated test setups and also from our test drives, and gave people feedback if they still had problems. And then they could also develop policies with the goal of, at some point in time, removing the permissive on their domain. This, from my perspective, is still also good practice if you do this in a system that exists. I mean, if you do it from scratch, you would do it in a different way, but often we don't do it from scratch. We do it on systems that already exist. Project management-wise, we agreed with everyone that they had now 6 months of time to create real policies. That gave everyone time to plan for this. We needed to do a little bit of interface management, because people that provide system resources need to provide interfaces for others to use. They needed to be a bit earlier. And we needed to manage the integration madness, which I would say, like, if you now have 100 people that want to patch your policy, if you do Yocto, you can't just have a source layer repo and everyone is just like putting stuff in, because then you get into weird scenarios where people want to now integrate and they can't because there's still other things in the pipeline. So actually for the services, we have put everything into a meta layer in Yocto so that people can integrate at their own pace. And in total, I think it took us a bit more than a year for this to be completed, but we actually succeeded and launched this in the infotainment system in 2022 with the BMW 7 series. So I think this was quite a success story overall. What did we learn? Well, it is a complex beast. I think this hasn't changed. But from my perspective, collaboration and support with the development teams is key. So you don't need to dump it on them and then leave them alone. You really need to be actively supporting all the dev teams. And only the collaboration makes it work, because they don't know how SELinux work in detail, and we don't know how their services work in detail. So you really need to work together to get good policies. And we invested a lot of time into helping them. I think this is really important. And it is better if you start early in development, because then you can put it to enforcing right in the beginning. People take care while they develop services. But you sometimes don't have this luxury. And yeah, it does get less painful over time. So we have smaller ECUs also that now started off also doing SELinux, because they say, we just have a few services with what you provide. It's almost for free. I haven't been expecting this, but it seems that people think about this nowadays like that. Good. Let's talk a little bit about trusted computing. So normally, if you do secure boot, it works like this. You have a hardware root of trust that contains a public key. And then you have a primary bootloader in ROM. It loads a secondary bootloader from flash. It uses the public key that you have. If the signature is good, it will execute it. And then your secondary bootloader might load a kernel from flash, use the public key that itself has, validate it. If it's good, it will execute it. And then potentially, if you have a more complex SOC, you have more bootloader stages, but we will ignore this for a moment because I think it's not that important. Your Linux kernel will at some point in time hand over to your user space, and then You have rootfs in Flash, and in modern embedded systems, you usually use dm-verity to protect this. I have a little bit of question marks here because there's multiple ways to get this set up. So that you understand this a little bit better, I want to give you some context. Why do I talk about this? If you have a large project, then you have several kind of build systems or CI systems that build the different stages. And depending on how you set up things, you might get dependencies between the different build systems or different build system stages. And this gets you into trouble when you want to release software. So decoupling is a good thing. And if you have public key crypto, this is good for decoupling because you just integrate into your first bootloader a public key, and then the other CI system can just sign with this private key, and you're good. You don't have a direct dependency between these two build systems. You just statically configure this at the beginning of the project, and then you continue. If you set up dm-verity with an init.rd, then you can actually do the same because you can just call verity setup in user space. You can have some code that checks a signature on your root hash of the dm-verity hash tree, and you have the same decoupling possibilities that you have otherwise because you can just produce a signed blob with the root hash, and then it's being checked as part of your init.rd, and then it's being loaded. But you have extra load time for the init.rd, which is something that we in some of our systems don't want. So you can use dm-init. This is a kernel feature, how you can initialize device mappers from kernel command line. Then you don't need an init.rd, but you need to pass really everything from scratch, from your bootloader into the command line, including the root hash. So either your bootloader now needs to be able to somehow validate your command line or your root hash, or you somehow need to provide the root hash to your bootloader in the build system. So this is a trade-off, and it would be good to have signature support in the kernel. There's something like this does exist, but it's not quite there because you can't read the signature from this. You need to provide it from user space, and you can't really provide the root hash in a signed form. If someone is working on this, would be great to get comments on that. Something else that we do when we work on Secure Boot, if you have a modern SOC, they often do support not only one hardware root of trust key, but multiple ones. For example, 4 key slots. Then what we do is we just say, well, the first key slot is for dev key, the others are for production keys, and now we can sign software with the dev key, or we can sign it with the production key. Then we can have actually hardware variants. We have development hardware where all the keys are active, and we have production hardware where we just say, well, the first key slot is being revoked, and now it will only execute production software. And this way we have some kind of mechanism how we can really produce real results, real release builds that are signed with a different key that are then runnable on our development hardware, on the production hardware. But if you have development builds, they still test all the secure boot things and they work like a usual system. You have no different timing and whatsoever, but they are not runnable on customer hardware. So if your SOC supports this, I would say this is a good way how you can actually manage this, and you can even read it from user space, so that some of the debugging functionality might be disabled if the first key slot is being disabled. Yeah, so last thing that I want to talk to you about is debug mode. So how do we debug production software? I said we have special debugging hardware, but we also need to validate quite some of the things on a final product. For example, our factories test things on the final product, so on production hardware. So we still need a way how we can debug this, and the idea is we have, again, systemd with a debug target that can start a serial shell, SSH, the more relaxed firewall, and we control this essentially with cryptographic tokens that are issued per device ID. So we have a unique device ID per device, we have a token for engineering mode, and then we have some backend system where you can issue those for development hardware. You then insert them via car diagnostic interface, and then you get SSH on your target in order to really do development work. And we have special deactivation mechanisms for other things. So for example, for SELinux, for dm-verity, we don't want them to be deactivated if it's in debug mode. You can deactivate them if it's necessary, but you need to do a little bit of more work here. So to summarize, what are my key insights, or rather our key insights as a whole team of doing this now for roughly 10 years? First of all, from my perspective, security is a system engineering task if you do this hands-on. So you need to have a good system overview so that you understand the implications that are coming from all the services working together. And you need to understand the features that we have, also to give guidance to the people that really develop them. KISS, so complexity is the enemy of security. Keep your things simple, and the dumber your approach is, the higher the probabilities that it really works. So what we also do is really try to reduce the complexity for projects. So we provide easy to use, hard to misuse APIs, for example, or scripts that make it easy to do certain tasks in a secure manner, but hide the complexity behind this. And we want to create awareness and trust, but verify. So we have this self-service approach for everyone, but we do reviews on critical things every once in a while and on things that we consider to be really security critical. And we have a self-understanding as a support team and not as a police team. This is also something that is really important to myself. So no one likes these kind of security people that just say, no, you can't do this. If you want to be heard in such a big project, it's easy to neglect something. So you need people to come to you, and they only come to you if they made the experience that when they come last to you, they have been helped and not been said what they can't do. So we need to tell the people what they need to do instead. And open source is almost everything you need. So I think there is no need to reinvent the wheel. You saw I use all the open source technologies that are available. Just like, I'm automotive. So sometimes you need a little bit of a new suspension. So some glue layers around open source software. And this is what your security team could provide. And I guess this is mostly it. And I think I talked too long. So I'm not sure if we do have questions, but I do have speaker office hours tomorrow, or we can talk in the hallway. I don't know. What does the time say? Maybe. Do we have still time? I think we have 3 more minutes for questions, right? Let's check. But I mean, we do. So who has a quick question?
The car is independent of your company. Yeah. So from the security point of view, it's somewhere outside where everybody can reach it. What is the implication for your model?
Well, I mean, the implication, so the question is, car is outside of our control, so what do we do? But the implication is that we do a as secure system as possible to begin with. This is why I talked a lot about privilege separation and stuff like this. And then we do offer software updates, but the customers do need to install it. So collaboration is needed at a certain level. Because, I mean, if their customers start being exploited because they have old software, the main thing that I can do is offer a software update that fixes this. Another question.
If I want to run Doom on a BMW, how do you go about it?
It's hard because so running Doom is hard because it's really locked down to quite a bit now. And we avoid GPL v3 for this reason, because we could actually do this and also could provide unlock tokens, but I guess the processes around this, no one wants to deal with this. I think we do have maybe time for one more question if you have one. So question is around how to create good seccomp filter. I think this is a hard question. I had a master's thesis with a student of mine on doing this, and let's say it didn't lead to a production-ready result, because you always either end up being not complete or over-approximating. So we do the low-hanging fruit approach. We just block out all the obscure things based on the rationale that they are not that often used, so they might be used for hacking because they are not that well understood. So in the end, from my perspective, security in a lot of cases is Pareto principle. So you get 80% of the success out of doing 20% of what's necessary. And the same we do here for SecComp. So we just block out the obvious things and you get 80% of the success out of this. Yeah. Well, it's easy to use. So I think for this reason, I'm happy with it. So maybe one last.
Does the future EU data have implications in
So
security?
can you repeat? Sorry.
The EU data that
So
comes into force,
the data privacy regulation.
yeah, implications and effects.
Yes, but mostly that we need to offer certain functionality in the first place. So it's a lot about doing encryption on data, doing encryption of data connections on the network, but we don't, so my team doesn't primarily take care of data privacy. We are involved in some of the discussions because people say we need to have some data privacy concerns being addressed. How do you do this based on your security knowledge? And then we provide consulting here. And we do provide disk encryption, for example, for everything that is customer data that is stored there, but otherwise, no. Good. So we are running out of time. So if you want something, feel free to visit me tomorrow. Have a good afternoon. Thanks.